In this lesson, we're going to be looking at inverse trig ratios, specifically sine inverse in this video. So you're going to use the inverse trig ratios when you're solving for a missing angle. Okay, so this is really important because if you're solving for a missing side, that's when you use the regular ones. When you're solving for a missing angle, you have to use the inverse ones. And I'll show you why that is in just a second. So if you have an angle that you're solving for, you would use the sine inverse when you have the opposite over hypotenuse information. So x degrees is sine inverse of opposite over hypotenuse. Then if you have the adjacent and hypotenuse information, you're going to use the cosine inverse. So x degrees is cosine inverse of adjacent over hypotenuse. And last, if you are looking for x degrees, you're going to use tangent inverse if you have the opposite over adjacent information. Right, so we're going to look at, in this next visual here, we're going to look at why we do that, why we use sine inverse. So let's say if we have this right triangle and we want to find angle x. So if I'm looking for the measure of angle x, I would set up the sine using the opposite, which is b, over the hypotenuse, which is c. So if I'm just doing the regular sine of x is opposite over hypotenuse, then in order to get x by itself, if I'm solving for x, if I'm trying to get that angle measure by itself, I have to get rid of the sine here. So just like with regular equations, when we need to get rid of something, we use what's called the inverse. For example, when we want to get rid of addition, we subtract on both sides. When we want to get rid of multiplication, we divide on both sides. So when we want to get rid of a sine, we're just going to do the inverse of that on both sides. So if I take the sine inverse on each side, that would look like, sine inverse of sine of x. So if I take the inverse on both sides, that would look like sine inverse of sine of x equals sine inverse of b over c. Okay, well, when I take the inverse and the regular sine at the same time, they cancel each other out because they're inverses. Okay, so that cancels and that cancels, and you're just left with the x equals sine inverse of b over c. All right, now let's try that with the y angle. So from angle y, the opposite is a, and the hypotenuse is still c. So my trig ratio, that equation I would use, is sine of y equals opposite over adjacent, so A over C. Now, if I were solving for y, I want to get y by itself, then I need to get rid of the sine. So to get rid of it, I'm going to take the inverse of it on each side. So that would mean I'm taking sine inverse of sine of y equals sine inverse of A over C. Okay, so I apply that sine inverse on each side. Now on the left here, sine inverse and sine are going to cancel out because they're inverses. And that just leaves us with y equals sine inverse of A over C. So as we go through this, we are going to be skipping this step here and this step here. We're going to be skipping that step simply because it's unnecessary. We are just going to understand that we're going to be going straight from our normal trig ratio, and we're just going to take our sine and make it an inverse on the other side of the equation. All right, let's do some examples, starting with just calculating this in Desmos. So we'll start with finding the measure of angle A. If we're told that the sine of A is equal to 0.5150, and we want to get A by itself, then we're going to take the sine inverse on the other side. So angle A is going to be sine inverse of 0.5150. So functions sine inverse of 0.5150, and then make sure that you are in degree mode. All right, so that got me A is approximately 30.9. So 30.99, that's going to bump up to 31 degrees. All right, for B, we're going to take the sine inverse to get B by itself. So sine inverse of 0.4848. And we're just going to type that in and see what we get. All right, I got 28.99, so again, that's going to bump up to 29.0 degrees. Right, now let's do a little problem solving. It says use the inverse, sine inverse, to solve for the missing angle. So even if we weren't told which trig function to use, we have this missing angle here. I'm going to call it x, just because it doesn't have a name. We have the opposite side, and we have the hypotenuse. So automatically, we're going to set this up just like we normally would. The sine of angle x is 40 over 42. Now our only goal is to get x by itself, so we need to undo or take the inverse of sine. So x is sine inverse of 40 over 42. So we'll type that in, sine inverse 40 divided by 42 gives us 72.24, so just 72.2. And that is in degrees. Okay, number 3. Again, I'm going to label this as x. We have the opposite side and the hypotenuse. So we're going to use sine of angle x is equal to the opposite 10 over the hypotenuse, which is 39. Now to get x by itself, take the inverse of sine. In case you haven't figured it out by now, the -1 symbol just means inverse. It is not an exponent. Just make that clear. All right, sine inverse of 10 over 39 is 14.85, so 14.9 degrees. All right, again, we have our angle x here. We have the opposite and the hypotenuse. So sine of x is 11 over 27. So x is sine inverse of 11 over 27. All right, let's see what that gives us. I got 24.04, so 24.0 degrees. Number 5, again, we have this angle. Just notice this triangle is oriented a little bit differently, but same process. We have the opposite over the hypotenuse. So that tells us to use sine of x equals 12 over 24. Now, I do want to point out that you can, since we're rounding, it's okay if you go ahead and evaluate 12 over 24, which is 0.5, right, or 1/2. So if you wanted to do that, you can. So you can simplify your fraction or find the decimal value and then do your sine inverse of that decimal number, but it's a little more accurate to use the actual fraction. So that's up to you. But in this case, since the fraction is exactly 0.5, we can do x equals sine inverse of 0.5. Function sine inverse of 0.5, because 0.5 is the same thing as 12 over 24. So that gave me 30 degrees. Exactly. So there's nothing to round here. I'll just put 0.0 if we're rounding to the nearest tenth. All right, number 6. We have all three angles are given to us here, or all three sides are given to us here, but it says to use sine. Okay, so since it says to use sine inverse, we need to make sure that we use the opposite and the hypotenuse. So sine of x is going to be 14 over 50. So x is going to be sine inverse of 14 over 50. So function sine inverse of 14 divided by 50 is 16.26, so 16.3 degrees. Now, when you have a triangle that gives you all three sides, you could use sine, cosine, or tangent inverse to find that, just depending on which sides you chose to use. In this case, we were told to use sine, so we had to use opposite and hypotenuse. All right, and this last one, it says use sine inverse. So again, we need to use the opposite and hypotenuse from the given angle. All right, so if this is x, we need to use the opposite side and the hypotenuse. So sine of x is 68 over 85. So x is sine inverse of 68 over 85. And let's see what that degree measure is, and we're going to round to the nearest tenth. That's 53.13, so just 53.1 degrees.